Alright, welcome back to the stream, folks. I think we might finally be back online after like a week since our last stream. Jeez. Looks like we have confirmation from YouTube and now from Twitch. You can see us live as a reminder. Well, reminder and sort of an announcement because it's still relatively new that I'm broadcasting on both YouTube and Twitch now. So as usual, you can go to YouTube, search for Scanlime in progress, and find all the streams, subscribe to my channel, and see the latest ones as they happen. But you can also go to twitch.tv/scanlime and get the same thing, assuming everything is technically working. So there's Tuco, as usual. So the main reason for the gap, the like week without streaming here, is actually cat related. So I ended up, well, I was about to say, I ended up kind of surprise cats, having to take care of some cats. I had some advance notice, I just didn't necessarily know when it was going to happen. So I had agreed to take care of these two cats that needed a home for like a month. And I wasn't really quite sure when I would end up getting getting to pick them up, but finally that happened, and suddenly, so last week ended up suddenly having a couple of cats to take care of. I wonder if we'll be able to see them. They are currently in the bathroom. You might be able to see just barely a cat by the tub. Let me see if I can get him in focus a bit more. So, yeah, that little one that you can see under the tub is Cloud. He's actually pretty big and puffy. He's like a big cuddly bear. At least that's my impression of his personality so far. And then there's also a sleek little black one that you probably can't see because she's probably hiding way back under the tub. So, yeah, those are my two little temporary cats that I'm taking care of for a friend of a friend, and Cloud and Luna. So I had them here for a couple days. They came from kind of a chaotic situation, and so they, and when cats move, they always usually need a little bit of time to acclimate to the place, so it's pretty expected that they come here. We give them kind of a cozy spot in the bathroom and a couple of days to just acclimate to that space, and that seemed to be going pretty well. And it was going so well that Saturday night I decided to let them out of this bathroom zone and just interact with the rest of the space and with Tuco. And that seemed like it was going alright for a while, but then I think something, I don't know whether it was something I did or just something that was occurring slowly, but the jealousy kind of came to a peak, and Tuco started getting really mean to both of these cats. Oh, now you can see Luna on the left. Yeah. Yeah, she's a beauty. For a sec there, it looked like Cloud's eyes were different colors, but I think that was just an artifact of the camera. So yeah, these two little guys, well, guy and girl. Luna's a girl. She's actually had kittens. And she seems like she's sort of a skittish, experienced little girl that's probably, she seemed like she was really good at retreating from Tuco when Tuco was starting to attack her. So that's pretty much what happened was, she was in the corner. It looked like Tuco was kind of going after her, and it looked like she was cornered. And so I tried to get in between them and kind of pick up Tuco, but Tuco was already in attack mode, so Tuco ended up attacking me instead and just clawing at me and screaming really loud, and it was pretty terrible for everyone. And then when that happened, I was just like, I was just trying to kind of keep Tuco distracted so that the other cats could get out of wherever they were hiding and then back to somewhere they thought was safe. And that lasted for a little while, and then I was trying to keep an eye on these two cats. Yeah, it was just kind of a stressful situation for everyone. And then found out that Luna made her way back to the spot that she liked under the tub on her own. But Cloud was stuck way back in this sort of crawl space behind part of the wall, and it was terrible. I ended up having a lot of help from my neighbor who's really good with cats, and ended up getting Cloud safely out of the crawl space, back into the bathroom, and then setting this little, this sort of mesh up so that they can see each other, but not interact too much, and then I can kind of gradually let them out for just a small amount of time at a time and keep an eye on them, that sort of thing. But yeah, that's been this semi-stressful but also pretty rewarding cat situation. It's been nice to have a chance to help out with some cats that need a temporary home and to at least get some experience in seeing Tuco react to other cats, even if it hasn't all been good so far. At least now I know more of what to expect. And Tuco's still over here peacefully sleeping in a box next to the rack equipment's warm air exhaust. Anyway, welcome back to the shop. The camera in a slightly different location. Let me try a different angle today. So, I actually had a vague plan for this. Well, I was going to start by recounting the cat story. So that was basically why this past week has been so hectic and it's been hard to find time to stream. It's not the only reason. I've also had a friend in town for a job search, and so it's been nice getting to spend some time with him. And it looks like he's actually staying, which might be nice. So, yeah, lots of good stuff and lots of stressful stuff, but it kind of added up to a week without a lot of streaming. So it turns out I've still got to finish that repair that we were doing before on that Delta printer. So that's on the queue. We'll do that a little bit later. But I wanted to tell you about the cats. I think we've taken care of that. I also had a few packages to unbox, so I went down to the post office and, well, I had this one, which I'd been waiting for sort of an unboxing stream for, you know, like, well, probably a couple weeks at this point, sorry. But this is actually a piece of hardware that you might have seen on the EEV blog or elsewhere on the internet. This is the, I think it's called the Trezor from Satoshi Labs. It's a secure Bitcoin wallet. And so we'll actually want to go into some more detail on this later, but right now I figured we could add it to the unboxing stream just so that we can have that experience. And then I've also got these two that I just picked up from the post office. There's this one, which I think, so this is from Ben Henke? Forget how you say his last name, sorry. But this is from Ben in Santa Cruz, and he's actually made a pretty delightful LED controller project, which is, you know, I mean, I made the Fade Candy a while ago, and I, you know, obviously had some interest in LED controllers. And so he's actually made a pretty great little thing that you can control over Wi-Fi. And so he graciously sent me a sample, so we'll take a look at that. And then here's one that I don't think I know I don't think I have a story attached to this one yet. So this one comes from Vincent Ebeacham, I think. And yeah, I don't actually know anything about this. So yeah, from Sherman, Connecticut. So we'll have a little bit of extra mystery with this one. So let's open these roughly in the order I just described them in and get the camera out. I got a few new memory cards, which a lot of people recommended these SanDisk Extreme Pro memory cards, and I'm hoping they can handle being really hot in this camera recording HD without failing quite so much, but we'll see. I guess you'll know based on how much glitchiness there is in the future videos. Oh, okay, cool. So I guess, oh, okay, Vincent Ebeacham. That's Vincent in chat. Great. Connecting the dots. Thanks so much. Awesome. I really should warn everyone that I have a really terrible memory for basically anything like human face or name related, so I'm really sorry if I forget you or forget your face in pretty much any circumstance. It's likely to happen. Okay, let's format this. Do we still have any of the other cats on the camera? If not, I might move it to be Tuco Cam again. I could still sort of see Cloud, but I'm not sure if it was coming through on camera. Yeah, by the way, this is all from Tuco. So that, and the scratches aren't too bad. The ones that are more like punctures are the ones that are still hurting a little bit. I mean, I know cat bites can be pretty nasty. I've had some, there was one time that Tuco was really excited about some food, ended up getting my thumb in there, and that took a little while to heal. Wasn't quite something that I thought I should go to the emergency room for, but yeah, they can get bad pretty quickly. And then this is an earlier one. This was from a few weeks ago when Tuco and I had a fire drill to attend to, and so I was trying to get him outside, and he was not having that, but yeah. I think there's still some blood on the floor from this past struggle. Oh yeah. I also, between these streams, had time to go to the Vintage Computer Expo that was happening this past weekend, or Vintage Computer Fair, VCF. So VCF West was in Mountain View, and I don't know, I'm like such a hermit, and I don't usually go to things, and it's kind of a bit far from my studio here. But yeah, a friend invited me, and we ended up going, and it was actually pretty great, and I got to meet a bunch of people that I've interacted with online, in person, which is always fun. Got to meet, so I got to see the Evil Mad Science folks, Wendell and Lenore, and they gave me a card, which is always nice. Can I focus? I got to meet Ken Sheriff, who we've talked on Twitter a bunch, but we've never actually met, and he brought his Alto restoration project, the Xerox Alto. So that was really cool. I got really excited about this whole architecture they developed, where it was like kind of this weird micro-coded system that had hardware threads, and very, very researchy even. I mean, I think it would be researchy in many decades, but really interesting to think about. There were some games where we were imagining how the games might have been doing their graphics loop by adding additional microcode tasks to the processor instead of just like writing basically user mode code. So yeah, let's open this one up. So this comes from Satoshi Labs, and I've got a letter that goes with this one, but let's open the package first. I can always do this in either order, right? All right, so we got a small package in the bigger package, throwing off my white balance. Ooh, got some tamper-evident packaging. Oh, lots of stickers. Whoa, a bounty of stickers. That's great. You could construct tamper-evident packaging entirely out of stickers. This is great. Oh man, I don't know what I'm gonna do with so many stickers, but I appreciate it. Let's put these together. Let's see, and then we've got the actual product, tamper evident and shrink wrapped, which is nice. Oh, that's neat. If you suspect this has been opened by someone else, they want you to send it back so they can diagnose it. That's pretty neat. Oh, I was just noticing what might have been a question in chat. Oh, yeah, was the PDP-1 exhibition open? I think it might have been. I didn't see it. I ended up not really getting to see much in the actual museum. The VCF West was in like its own room, and my friend and I, we ended up like just spending most of the time in that room, and then by the time we ended up trying to go explore the rest of the museum, they were about to close, and so we ended up leaving. So yeah, I didn't get a chance to see it, but I'd like to. It seems really cool. I only ended up going to VCF on like Saturday afternoon, basically. And then Jarrett's asking for the Twitch link, and then Vince actually got it, so great. Thank you. Going to VCF. So what's in here? Like Saturday afternoon. Is this like some additional hardware, maybe? Uh-oh. Oh no. Oh, thank you. Yeah, maybe I should mute this machine just in case. There we go. Just in case that happens again. I don't really worry so much about the video because that's easy to ignore and then delete, but like who knows how aggressive the content matching filters are these days with audio, right? Oh, great. This is a spare circuit board. But yeah, if anybody yeah. So one warning about the Gitter chat is apparently if you post a Twitch link, it'll autoplay. It's the stupidest UI decision. But yeah, that's the way it is. And if you want to get my Twitch, it's just twitch.tv/scanlime. Like scanline, but fruitier, right? Cool. So this actually, if you've seen Dave Jones' video on this board will look familiar. He, I think he tried to replicate the power analysis attack briefly and kind of did a tour of the board, basically. This one also looks like it's not been conformal coded, whereas the one that I saw in the screenshots on Dave's video looked like it was. So that could be convenient. Oh, great. This will be super fun. I don't know if I want to open this package like right now, since that might be a nice thing to do on a later stream that is specific to this device. But yeah, let's keep this handy, especially since it looks like we've got the actual board right here so that we can take a look at this quickly. Maybe we can even get this onto the microscope. It looks really self-contained though, like we've basically got an OLED display, an STM32 ARM, I think that's an STM32, to the microscope machine. Oops. I say as I forget which button it is. Yeah, that's an STM32. So yeah, that's cool. And I mean, the basic idea behind this design is that you implement this in such a way that all of the secret data is only accessible to the code running on this CPU. It never crosses any external buses. You know, you're doing crypto with keys that are stored in memory on here that's protected, at least as best they can, with the hardware features available, which will mean that you can't run external code on this device and then read the keys back out. We'll have to look at the data sheet to see what features this has that they might be taking advantage of, and then maybe try to find some more details if they're available publicly about what features they claim to use, and then maybe do some investigation to see how robust that actually is. But I think maybe the next step is to take a look at the note that came with this. That's the programming header unpopulated. Could probably also power this up and just look at the LED or the OLED screen come up. Yeah, so in case this wasn't clear, this is a Bitcoin wallet, as Robert says. This holds money. That is what it does. Let's see if we could just get any anything on the screen from powering it up. Cool. That seems right. Well, that's convenient. So we can go ahead and start poking around on this one without even having to open the tamper-proof seal if we want. Yeah, let's take a look at some of the supporting materials we've got. So yeah, here's the note I got from them kindly, from Pavel. So yeah, for introduction here, it's a cryptocurrency wallet, and I mean, basically, a full-size computer is super hard to secure because there's just so much stuff that goes into it. So the idea behind having a little like doodad that you carry around that's in charge of keeping some small piece of information safe is really about reducing the attack surface and making something where you have some chance of actually keeping it reasonably secure. Yeah, and that's nice. So normally when you have like a universal two-factor authentication doodad, you can just like put it in and it generates credentials, but and then you're not expecting that that's your only line of defense. The name two-factor implies that you're combining that with something else, like a traditional login. Whereas with a Bitcoin wallet, like it's got to be pretty secure against as he's saying, you don't want it to blindly sign transactions. You want to have, you don't want some software that's, for example, rootkitted your desktop to then communicate with your token that just happens to be plugged in. And you can imagine something worst case where like you're doing a regular transaction, you're buying something that's like $10 and you plug in your card, and then the rootkit on your computer then uses that action where you've just plugged it in. You could imagine something where maybe it modifies that transaction or does multiple transactions. You could have like timers or other limits, but having an actual display that lets you specifically confirm seems like a great idea. And yeah, a PIN code. So, and then they're linking to this previous power analysis attack, which is a pretty great write-up. And then, yeah, also Dave did a video where he takes it apart, and I think he tried to reproduce this. I don't think he had much success, but I'll have to look at that video and see what actually happened. And yeah, this other point is really good. That one thing that's really unique about this kind of device, where it's basically a vault that is supposed to do a pretty good job of holding your secret, it doesn't have to be as secure as, like, the reason you hear about these DRM schemes failing all the time is because they typically rely on a single key that, like, all the Blu-ray players, or a small family of keys that all the Blu-ray players have to know. And if one motivated person out there figures out the scheme, then they crack the entire system. Whereas that's not going to be an issue with something like this. So yeah, this would be really interesting to dig deeper into. Especially this, it looks like a fun read. Yeah, and this is really nice. This is the annotated power waveform, where a lot of this is screen refresh, and so you can use that as kind of context for what's going on. Very simple setup too. It's just a hacked USB cable with a resistor. So you're going to see only pretty low frequency changes in power consumption, but it's enough to look at timing differences. Yeah, and so as like I said, I'm terrible with names. I'm so sorry. As Pavel mentions in this email, that they collaborated with this person, Jochen, I think, and they ended up updating the firmware to compute the pin, or to do the private key computation in constant time. So that would be interesting to verify. That might be what Dave already did in his video, though. could take a look at that too. Anyway, I will save the juicy bits of this for a video where we can give them the attention they deserve, but thanks so much for sending in that bit of hardware. This will be an interesting little puzzle to dig into and see what the security of this real-world device might actually afford. Great, well thank you. Let's dig into the next package here. Maybe focus the cat slightly. All right, so here's the next package from Ben. Get some Blinky on in our lives, perhaps. Oh, here's the scissors, before I use completely the wrong tool to open that. Sweet. Looks like that's our thing. Wow, that's great. So ESP30, is this ESP32 or no, ESP8266, cool. And then we have 5 volts clock data ground. And I think these are designed for, oh, there's the air compressor kicking on. I should go turn that off. Alright, so we've got an ESP8266, looks like a few extra GPIOs and a serial port, and these go to the LEDs, and I think this is designed for APA 102 or similar SPI LEDs, but let's take a look at the web page. Yeah, here's the thing. The Electromage Pixel Blaze, which is a great name. Yeah, so it's got a little built-in web server where you can edit patterns. Here's the wiring. Okay, yeah, API 102s. Yeah, HDR color, that's nice. And built-in level shifting. That's these 2 transistors, I assume. Oh, cool. Is there a link to like a firmware getting started thing? Assume we want to go to like a GitHub page or something. Oh yeah, I mean, looks like there's an interesting discussion about the consequences of securing a device with a bunch of Bitcoin on it in the chat. And yeah, it'd be interesting in that You know, it's like there's a question out there is basically how much money would you trust to put on a device with a particular level of security? Because at some point, obviously, you know, if you put like all the money in the world on this thing, then someone's going to figure out how to get it out, even if it takes a focused ion beam, and like destroying hundreds of other devices in order to get the data out of this one. But most people, it's not going to be worth their time. So somewhere in the middle, there's probably some amount of money at which you would no longer want to trust it on a device like this. But I imagine that amount is probably fairly high. But it'd be great to know, right? I don't know if that's gonna... Maybe we need to search for firmware? I mean, it's probably got firmware installed. I just want to know, like, how to use it, how to tell it to connect to what Wi-Fi. It's probably just going to start its own access point, though. Yeah, I guess let's just wire up some LEDs and plug this in and see if we can at least get some signs of life out of it. That would be nice, right? I don't have a long strip of these LEDs handy, but I have this little offcut that we could wire up. Let me check real quick. Most of my stash right now is still WS2812s. Yeah, I think these are all 2812s, and I had some APA 102 that I mostly... Oh, I was gonna say I just used in the Tuco Flyer, but we could like connect one of the Tuco Flyer rings to this because they're already wired. That's easy. Let's just do that. What do you know? Great. Just need a screwdriver. Oh, great. It looks like Fred found the getting started URL that I was lacking. I appreciate that. Stop wobbling, camera. Ah, these silicone wires are really nice. Let's check out that getting started link. Yeah, we got the right kind of LEDs. Cool. Okay, so you can power over USB or from the screw terminal. That's nice. Okay, so there's like a setup network. Okay, let's see if we can do that. I think... Oh, can we do Wi-Fi from this machine? Alright. It doesn't actually need the Wi-Fi. I don't know why it's even on right now. Okay, let's turn this on. Appear to need, here it is, micro USB cable. We got plenty of cat. Okay. We have some pulsing now. That's nice. That's a fairly pleasant way of not being configured. Let's try to rescan here. It seems like we should be getting a network now. I didn't see a mention about what color it should be flashing, but maybe that doesn't matter. Okay, yeah, setup mode means pulsing yellow-orange. So yeah, we should be in setup mode. We should see Wi-Fi right now. Oh, there it is. Great, Pixel Blaze. I keep having to reset this keyboard. Is that it? Oh, 192.168.4.1. All right. Oh, we're not getting an IP address. Okay. Oh, now we are. Okay, fine. That seems fine. It's not going to conflict with this. There we go. Let me just get this on my guest network. Actually, if it's on the guest network, I can't really talk to it easily. Oh, this is slow. I wonder if it's signal problems. Because this machine does not have good Wi-Fi signal. We could try doing it from my phone. Although, I couldn't really stream that, though, because I'd need the Wi-Fi to stream it. Can I just click that? Configure Wi-Fi, no scan? Okay. Cool, I'm going to give it the SSID and password to my real non-guest network, so I'm going to blank this for a sec. We'll have some cat. when you enter the Wi-Fi username and password in the form, it then redirects you to a page with the username and password both in the page URL. So I'm kind of glad I did blank the whole screen. Not that that password is super valuable, but all right. So now it says credential saved, trying to connect ESP to network. And I think now we're waiting for the LEDs to start blinking a different color. So this is what we've got. I blanked out the URL because otherwise it would have had my credentials in it. Thanks. And here we go. It's drawing 120 milliamps according to this power supply. Not sure how long this part should take. You know, it's also possible it's like connecting to my network, and now I just don't know what IP address it has. Let's see if there's anything next in the getting started that covers this. Oh, so they're just like nmap it. Is this SN? Is that like a reverse hostname lookup? No, that's ping scan. Does it... Oh, are they just... How is this recommending that we disambiguate it by host name? Is nmap just going to do that? I guess we can just nmap the whole network at this point. I mean, there's a bunch of stuff on here. We could just guess, okay, what's the... start guessing host names here. You were not supposed to Google for that. We want something that's answering on port 80, right? Now we just get to take a safari through all whatever random IoT I have on my network right now. This is... I think this is a camera? Cool. Well, those aren't both cameras. 53 and 77. Oh, here it is. Great. Oh, now it's just running. That's convenient. So I can just click one of these and edit it. Yeah, I mean, like, if this could do a multicast DNS broadcast so that you could just go to pixelblaze.local, that would be pretty cool. There's also the thing that like Raspberry Pi does, where there's like a desktop app you can get that'll help you find it. But yeah, having to go on a Safari on your local network to locate it is a little bit annoying. With that said, everything else about this has been pretty awesome so far. So, Saved Patterns tab. Is this like a real-time view of what's going on the... I think so. It says over here, frame rate, instructions per second. Let's get this compact enough that you can actually see it on the screen. Yeah. That is glare from the window. That is not a white LED on the right side. This is great. Yeah. Is there something that would be fun to edit here? So we've got some kind of wide color bands that go back and forth, it looks like. Time. What does that time do? Oh, nice. So these create oscillators. Yeah, this is really nice. Okay, so what are these? T1, T2, L4. T1 is driving these inner sine waves. L4 is modifying just that part of this expression. What is I? Current pixel. Oh, so this is like the size of the little blips that we've got. Is L the length of the whole thing? Yeah. Oh, okay, this is length times 4. So this is creating... Yeah. So this will go from 0 to 1/4 over the length of the whole strip, I think. I guess that must be like a color wash. Yeah, that's computing the hue. Why is hue B? Okay, B is hue. That's fine. And this is making a nice 4th power nonlinear brightness. Robert is asking, is it a custom DSL? Which by that I assume that they mean a domain-specific language, and it looks like the answer is yes. It looks like it's just a simple expression language that compiles into some kind of virtual machine. Yeah, the fixed point mouth is pretty nice. I appreciate that. So let's try simplifying this a bit. So we've got HSV. Is the last line in this expression just the result? Yeah, I think so. And HSV just generates the color. What is the actual color format here? Oh, this sets the current pixel. Okay, so this is like an output function that you're calling. Hue wraps. Saturated, saturation and value clamp. Okay, that's nice. So if this was not to the fourth power, then we would start to see a much smoother difference between the bars and not the bars. Oh no, why is it much? Whoa, that's not what I expected. Okay. Generating. Oh, that's interesting. Okay, this is... So what did I just change? I changed this from being a to the fourth power to just a. Can we undo that? I don't think undo is working. Oh, maybe my keyboard is having problems again. There we go. Okay, so you don't even have to press save, it just does this online as you edit it. Okay, so this is value... what is A? So this is another sine wave oscillator based on this timer T1. So this is just like a sine wave that it's going to have kind of a fast period relative to the length of the strip, and then it's also going to be moving as time progresses. So that's actually creating the shape of these bands. At least that was my assumption. And then this was causing that hard edge by taking that shape of, like the shape, and then raising it to the fourth power. Oh, was it just looking different because we were having to deal with negative numbers now? Would it... Maybe I would get the result I was expecting to get if this was absolute value. Do we have absolute value? I don't know. Okay, let's try squared instead of to the fourth power, because that'll have the same effect of taking the absolute value. Lost the keyboard again. There's some kind of electrical thing that's a little marginal going on there. Oh. Maybe the thing that I'm noticing is just this extra color fringing on the edges of the pattern. Maybe I just wasn't noticing that before with the edges. Huh. Interesting. There's a lot going on in such a simple looking pattern. Maybe it would be more fun to start with something new. So let's start with HSV. And I'm just going to use this as kind of a monochrome placeholder. We can colorize it later. Hue, saturation value. And so what if we just wanted this to be a gradient? This would be like I over L. Is that right? Yeah, okay. And then if we wanted that to... If we wanted to base this on a sine wave, do we have pi? We do. We even have 2 pi. Okay, so there's one sine wave, and you'll notice the second half is all black because it's been saturated from negative to 0. So we're only seeing the top half of the sine wave. It's been rectified. We could shift this up. And then what we were doing before was just taking this to the fourth power to kind of make it more, like have it, to give it kind of steeper edges. So it'll look a little less blurry, basically, is what I would expect this to look like. And we're seeing the other half of the sine wave because now we're rectifying that back up to the top, the positive half of the y-axis. Cool. I wonder why it looks like, I don't know if this is just an artifact of the monitor or something, but it looks like we've got these bright peaks and then it's like a little bit darker in the middle. Is that real? Nope. That's just an optical illusion. So then we could add a timer to this to make it animate. So this basic timer loops between 0 and 1. Whereas this just kind of includes multiplication, which might be nice if we're doing something circular, because then we can make it loop at the edges of the circle, which you know, will prevent discontinuities. Oh, interesting. So is this one up here running live in JavaScript, and then this one's running in a simulator? Yeah, that top one updates first. And then so this first number is the period, so shorter should be faster, right? If I update my keyboard from unplugged to plugged. Yeah. Neat. So can we combine? I'm wondering if you can do multiple HSV conversions and then combine the results. Doesn't seem like you can capture the output of that HSV function. Okay, so what if I call these, let's use names. RBG. So, wow, this keyboard. Yeah, so you could do something like this where you color it in RGB space and then just sum these together to have multiple blips. Yeah, this is fun. Anyway, I shouldn't like spend the entire video playing with this, but I probably could, and that's a good sign. Yeah, a lot of nice built-in functions, and I can see how you could build up a lot of interesting functionality just by using the basic primitives here. Anyway, this would be more fun to edit if my keyboard didn't keep dying, so maybe I'll do this in a bit. Alex says, so what is this thing exactly? Well, it's an LED controller. It's called the Electromage Pixel Blaze. And so Ben Hank sent me one of these, and it's a really neat little device. He's got some great projects too. This thing here looks awesome. He's actually got a web page for it. Risk using the keyboard here to go to his site. I'm sorry, I'm having keyboard problems. I mean, they're like USB signal integrity problems, I'm sure. Yeah, so he's got this glowing keyboard project called Cynthia. It's really neat. Let's try and make this not be super loud, but I think you'll appreciate it. Yeah, so it's kind of, this is another one of those things where I just want to see this in person, because I know it's going to look even more amazing in person. But you might notice there's a a pair of hands at the top of that image. There's a keyboard, and as you play, the sound waves kind of create these streamers of light that move back. And this one actually has some really interesting visualizations, and it's really peaceful. You should listen to it without me talking over it sometime. Let's see, and this is actually a really nice explanation too. With prototypes, yeah, it's got some really interesting features. This is a NeoPixel ring with a capacitive touch sensor in front of it made from just a circuit board that LEDs shine through. It's really nice. Yeah, here's like a pixel view of the visualizer output, which might be a little easier to see on the video than with the LEDs competing with the camera's shutter. Anyway, so this is Ben, and he also designed this LED controller, the Pixel Blaze, and so that's what we've been playing with here. It's an ESP8266 with a neat pattern generator and a JavaScript UI that lets you play with the patterns and test them out in real time. So yeah, I think that's probably a good stopping point for this, but this is super fun. I'm going to have to play with this some more. Thanks so much for sending it. Yeah. Like, kind of lamenting that I've got all these APA 102s that are slated for a different project. I've got to order another spool of these so I can just play with them with this controller now. Sweet. Okay. Next package. Oh man, I'm gonna have to try programming these from like an iPad or something, because that could be pretty interesting. I mean, it's nice that it opens the possibility of just using so many devices. Alright, so this one is from Bensei in chat. Thanks so much. Let's see what it is. I have no idea. It's possible you already told me and I forgot. If so, I'm sorry. Station 240 says you could try soldering a new USB cable onto the keyboard. I don't think that's the problem. I neglected to mention the Rube Goldberg machine that this keyboard is plugged into, which I would much sooner blame than the keyboard itself. Oh yeah, I was not saying Ben Heck, in case you're familiar with Ben Heck. Ben Heck is a different person who makes completely different things, which are also cool, but not quite in this way. No. Whoa, what is this? These look, oh! Are these really nice surface mount probes? What are these? So this looks like a nice part organizer thing. Are these like little, do these hold like surface mount passives? These look like they're for surface mount parts, for doing like manual pick and place with tweezers. That's great. And then these are really tiny grabbers. Oh, and they come with leads. Nice. I hope these aren't aluminum. I've got so many aluminum leads in my shop now. It doesn't really matter if they are. Oh, they feel better though. They probably aren't. Ah, Vince says it's a case for these probes. Delightful. Ah, yes. Alright, well unfortunately I can't see the warnings, but it probably is like, be gentle with these, don't hurt yourself, don't break them, ESD, that kind of stuff. So the short end goes on this plug, the long end goes on your IC, and then you grab it, and I assume there's like a pulling motion, and then the end of it sticks out. Let's try that. Alright, so one end goes on here, the short end specifically. Okay. And by pulling that toward the... Oh, this lighting situation's not great, is it? Okay. There we go. So by pulling that toward the wire, it sticks out the probe. That is beautiful. Yeah, and see how they cross each other and then form this little hole that the wire is trapped in? That's great. James deciphers it as "do not poke the pokey bits in eyes." Yeah, that sounds about right too. Ah, well that's great. Ah, well thank you so much. These will be great next time I have to get some signals off of some SOICs or probably TQFPs. That's delightful. Nice. Do these all get an individual spot, or do they go in twos maybe? Oh, I think they get individual spots. Wow, that's great. Well, that's enough probes to, to do pretty much anything you want with serial flash, for one. Ah, well, that's great. Robert asks if these are small enough for TQFPs. Let's find out. I'm sure I've got... Here's a TQFP. Let's do this under the microscope, because, of course. Alright, this chip is dead anyway, so we can do anything we want to it, right? Yeah, that looks pretty big compared to the TQFP. There might be a chance. That's not gonna do without shorting its neighbor, probably. Yeah, definitely better for SO. Might be usable in a pinch if I really had to get something off a TQFP. But, is there an SO around here? We can show how it's designed to work. Here's an SO. Yeah, so that's a really secure connection that's not going to short to any of its neighbors. That's great. Could also attach to a button if you really needed to pilfer someone's reset signal, maybe. Or a crystal. Really need to know about that 32 kilohertz. I wonder if it's any easier to grab a corner TQFP pin. Yeah, the danger there is shorting out the neighbor. So probably not practical, but worth a shot. Alright, cool. Let's see what else we got in here. Ooh, got a bag, got a paper, and a box. Ah, yes. Okay, I think we had talked about this. I think they offered to send me this Cypress Super Speed kit. Ah, yes. This looks super fun. I don't entirely know what I want to do with this yet, but I don't know, like I've always enjoyed using USB as a high-speed pipe to just shove data into the computer and do something fun with it. And so, yeah, I would love to play with the FX3. And this FX series is basically Cypress's kind of main, like, USB system on chip line. The most infamous one, at least the one that I'm most familiar with, is the FX2, which it's still actually really popular. Like, a lot of the Salier logic analyzers and similar devices use them. It's basically just a pretty nice little, you know, high speed, so in this case 480 megabits per second for the FX2, a high-speed USB serial engine, plus basically a programmable hardware state machine that you can use for interfacing with various peripherals, and then a little 8051 8-bit microcontroller core. So that was the FX2, and it was massively popular, and I did a few things with it, used it for some FPGA-based projects. And then FX3, you know, so you might imagine that with all the extra bandwidth we're dealing with, you'd need a bit more processing. And so, as you can see, we have an ARM9 microcontroller with a 0.5 megabyte of SRAM, which is pretty formidable here. We've seen these chips. I think the last time we saw one of these on stream was inside the Tobii eye tracking camera we took apart. I think they were using one of these as a camera controller. Ah, yeah. SRAM enable. Demonstrating the USB transfer rate. Always something you gotta do on one of these boards, right? But that is actually an important thing for the silicon vendor to give out, because actually getting the device's maximum throughput requires some fairly careful software design. So I'm sure they end up with a lot of people complaining that the hardware doesn't give them all the throughput they want, and they just haven't written their software in a way that's capable of that level of efficiency. Like, you know, the biggest thing is usually writing software that can handle multiple overlapping transfers at once, so you can be requesting that the OS do one transfer while another one is already pending. Wow. So what is that big thing on the back? Is that more memory or something? This one on the front is the FX3. So on the top side, we've got the FX3 in the middle, power, USB serial debugger. That's interesting. I don't see a mention as to what's on the other side. What is this chip? CY7C1062. I'm guessing that would be RAM, but that's interesting. I'm sure we can get more info out of the documentation for this kit. Let's see what else is here, though, before we get too distracted by that. So we had a note and weeds, which we already looked at, and this contents. Oh, nice. Vince has a link there for the SOIC clamps we were just looking at. So I guess they're advertised there as TSOP, TSSOP. So you could use those for parallel flash memory too, basically. Oh, nice. So we have a 2.4 gigahertz antenna module. This is the NRF24L01, which is a really nice chip. You'll see it. I mean, so it's pretty basic. Like it's 1 megabit, I think, GFSK modulated 2.4 gigahertz radio. But it's just so common and so easy to use that you'll just see it everywhere. So they're great little radios. And we've got a pinout. And then a GPIO expansion board. I wonder what chip that has. Oh, and then the clamps we just took a look at. Okay, cool. Well, thank you so much for sending these along. Let's see what we got in this bag. Oh yeah, these look familiar. Yeah, these little radio modules are great. I did a project a while ago where I made a video game system out of a chip pretty similar to these. Not just the radio itself, but there's a version of this that's a system on a chip with an 8-bit micro. And so I basically wrote a graphics engine for it, and that was fun. Cool, this is the Raspberry Pi I/O expansion board. We've got a bunch of push connectors on the top. I'm curious what this chip is. Ooh, a bunch of hardware. We've got standoffs and screws, jumpers. Oh, these are fun. These are the kind that you push and then it clamps onto the wire when you let go. Oh, okay, maybe this, when I read I/O expander, what I usually assume that's like a thing that hangs off the SPI bus and gives you more GPIO, but I think this might be more like a wiring breakout board. Because this plugs into the Raspberry Pi header, it gives you a pass-through header. And then you can use shunting jumpers, which they provide here, to connect those signals to, 1 through P. And I guess the way this works is you can just connect them straight across if you like, or you could use patch cords to wire them up in some other way. Yeah. Oh, well, that's handy. Yeah, even having like the SPI and all that labeled is pretty nice. Cool. Well, thank you so much. This will be a nice little addition to my lab. Yeah, in fact, this thing plus the Raspberry Pi plus this little cord, and you've got a pretty good little SPI flash programming station. Oh, yeah. Well, this is great. Well, thanks so much for sending all the goodies, and we've got at least a few things here that could be entire videos all onto their own. So, for sure, the Bitcoin wallet, and taking a look at the oh geez, I'm so bad with names. Pixel Blaze. Yes, the Pixel Blaze. I want to experiment with that a bit more, and then I can at least maybe do a little video on that, because that would be super fun. And then this FX3 kit. So yeah, ARM9, half a megabyte of SRAM. Yeah, well that's great. Well, let me know if you have anything that you'd love to see me do with any of this stuff. I will certainly be thinking about what we could do that would be as interesting and as informative as we can muster, but if you have ideas or things that you would love to see, I would love to hear about them. So as always, you can ping me on Twitter or write me an email, and I would love to hear from you. Alright, well, I think that does it for today's unboxing. So I think the next thing I had on the list of stuff to do for today's stream is actually doing a bit of a pirate print run. Robert says, let's count how many times scanlime crashes the USB driver stack before it starts actually working. I assume this is in reference to the USB 3 device, and yeah, that seems about right. In a previous life, I worked on USB 3 virtualization, and the weak link there was definitely the driver stack. It was very fragmented at first because it was kind of hacked together by the silicon vendors who were working on USB 3 chips before the OS was really especially ready for it. And I still don't know if that's really gotten better. So I guess we might find out. I suspect it's gotten reasonably better on Windows. I have less hope for Mac OS, and it's probably fine on Linux. Alright, so printing. First 2D printing, and then 3D printing. Pirate printing. Yes. All right. Ryan says VMware support for USB 3 is still abysmal. Thanks. What do you even mean by that? I mean, if you mean that when you call up customer support and ask them to say something smart about USB 3, it doesn't work, then maybe I'll agree with that. I mean, we had USB 3 working in a VM for so long before anybody actually cared enough to add a checkbox that would enable it. Messy, but that's fine. So this is what we'll be printing from. This is a linoleum block that I engraved in the other mill, and I made a little 3D printed jig such that you ink the block and then you press the block down there, and then you tear off a page. And I tried doing this with black at first, just using black printing ink, and the problem there was really that I just didn't want that much contrast, since this is designed as kind of like a notepad with a grid on the background, and so I want you to be able to write over it and see through it. Having really dark printing kind of, negates the purpose of it all. So then I tried this other crazy idea, which was to use these stamp pads, but not really enough ink transfers from the stamp pad to the block. So now I'm back to basically trying to do more of a traditional block printing with a roller, but pink ink instead of black, which I think works pretty well on the white. Yeah, I basically made a little printing press kit for this thing. I think I just need a little spatulating device for this. I'll just use a spudger. I don't think I need much ink, but I need to be able to form a thin layer. So I need to put out the massive disclaimer that I'm certainly no expert in printing, and I'm probably doing it all wrong. That said, I think the goal here is to get a really thin and even layer of ink on the glass, and by proxy the roller, and then by proxy just the very top parts of the printing block. So I think something like that. Oh, that's bright. That might have been a little too much ink, but pretty decent. Version 2.6.0 is coming along fine. Cool. And these will just kind of litter my desk for a sec. So, I'm just going to do this a little, and we can have a fresh supply of notepads. So far, I've just been making these for my own use, but if people are actually interested in these, it might be kind of fun to try to mass produce them somehow. But I don't know if it's worth it for such a silly joke. Ooh, we got a rare double impression on that one. No, it is not compatible with your old netbook, I'm sorry. 64-bit only. No legacy support in this version of DaveCAD. It also requires an internet connection, which kind of sucks. Yeah, that shifted a little as it was printing. Robert says I should do intaglio printing so that it can be more secure. I forget what intaglio printing is. Is that the stuff where you have really a really complicated machine that prints like a spiral pattern or something? Something that's kind of hard to reproduce without that particular complicated machine. This bright pink ink is pretty amazing. No, this version's not subscription only. You can, anyone can print these, right? But you have to have the hardware, right? You can buy the hardware by subscription. And the files are free. Don't want this bulk of ink to dry out. Oh, that one got an impression from one of the border lines. That's cool. It's nice when they're all a little different, right? Oh, intaglio is about the raised feeling. Interesting. So yeah, this past week I feel like I haven't been as productive as I like to be on account of the cats and also not being quite as much of a hermit as usual. So it has its upsides, but also means that I haven't really gotten to the point of having much to show for the robots. On the last robot related stream, we got one of the winches pretty much completely assembled. It's still missing the outer shell, but aside from that, it's done. Well, and it needs a little bit of software. So that's the thing I've really been dragging my feet on, is they need more software. And that's what's been suffering this past week or so when I haven't had as much time to devote to that. But at least got some of the sysad mini tasks that I needed out of the way, like, setting up backups again and getting the Windows machine so I can SSH into it. I still need to figure out which Rust joystick library to use. It's just one of those things where I guess there's like a small group of people out there that are using Rust for video games, and so there's a small group of libraries related to that. But trying to find something that has the intersection of, is pretty maintained and works cross-platform and supports the joysticks that I have and still builds on current Rust has been... Like, there's this library, GIL, the game input library, which I think is the closest thing. I was just having trouble building it, and I need to figure out whether it's my problem or their problem and fix it. Oh, that's a good question. Vince asks whether it's hard to add another target CPU to QEMU. That is a good question. Doesn't it use like an internal sudo op format? So there's like a translator you build that goes from your architecture to sudo ops, and then it can work on there. But I've never actually done that. I did add a backend LLVM for the Siftio project a while ago, but that was different. This is really nice and pink. That probably still has enough ink on it, actually. Kind of. Anytime people are talking about HID raw, I always think it's like high draw, like for high-res graphics mode. See, some of these with lots of ink are going to have like a little bit of a raised feel to them, probably. I think I've got too much ink on the glass right now. Oh, himem.sys, yeah. Yeah, I think I might have just had like Apple high-res on the brain from going to the Vintage Computer Expo. There are some amazing little machines there that people have worked on, and some amazing machines that could use some more love. I don't know, it's a weird little hobby. I mean, I like it, and I understand why people like it. It's also kind of weird. But, I certainly share a nostalgia for when computers were simpler. have to say, soldering on this stream I find pretty relaxing, but printing is also pretty relaxing. There are some videos going around. Oh, I'm forgetting who linked to them originally, but somebody had linked to these videos on Twitter about, they're just like instructional videos on soldering from Pace, who I remember seeing just like ages ago, you know, in like electronics magazines in the early 90s, I guess is probably what I'm thinking of, like advertising soldering training and soldering equipment. And so someone pointed out that their videos are all on YouTube. And it's this like pretty dated but still useful kind of stuff. And the way they talk about soldering as this process of transferring heat and then like wetting the metals and preventing oxidation, like they go through all the important theory behind it, so you can kind of get a picture of what's going on, which I like. Now it's back to about the right amount of ink. I had too much ink on it for a bit, but now it's evened out. Next project, DIY inkjet printer head. Yeah, maybe. I mean, that sure would have some applications, wouldn't it? It'd be interesting to know, like, I guess if you're making an inkjet from scratch, you could probably design it to work with a lot of different kinds of liquids, things that are maybe thicker than regular inkjets can deal with. I don't know how inkjet ink compares to this, but I would expect it to be pretty thin. Oh, nice. Thomas says, hey, I have a weird nostalgia for vintage computing despite never being around for that era. Well, that's cool. That's kind of encouraging, actually. Yeah, I'm curious what it is for you. I mean, like, I would guess that it would have to do with the way the hardware was easier for just individuals to understand and work on. But yeah, I'm curious what the draw is for you, especially if it's not just nostalgia for something that you were part of previously. I kind of want to just make something really pink with this ink, which I agree could happen by accident. I guess there's a video game people have been playing about that lately, which seems fun. I still haven't gotten that system. Have not been that much of a video game person for the past decade or so. I think now maybe it's starting to get to be a little low on ink. Maybe I could add what's on that spatula. Delicious. Oh, that's cool. Robert says, I seem to recall reading a blog post where some guy hacks an inkjet head to print with some kind of low melting point wax. Yeah, that would be interesting to read about. Oh, cool. Thomas has an answer. They're saying, yeah, it's kind of the simplicity. I got into the NES community and ended up doing stuff with that. I ported Zork to the NES, and that was a lot of digging into Z-Machine innards and 6502 ASM. Now I want to be an embedded developer, which is more of the control over the whole system and connection to reality stuff. Yeah. I liked that connection a lot. Like, I remember as a kid, well, like, how old was I? This was maybe, I don't know, like early teens, I guess, was when I was getting into this, just thinking, like, that was when, like, it was easy to, well, easy. The thing that was accessible to me at the time was plugging LEDs into the parallel port on my dad's IBM PC when he wasn't looking. And And like I would read books about how, oh, if you have a computer with like a user port, like a Commodore, or like a parallel port on your PC, here's a circuit you can build out of this pile of transistors that'll drive stepper motor. And I remember thinking like, oh, that would be great. I could build a robot. And I got as far as making a chassis for the robot out of like Meccano erector set. But then I didn't actually have any computer to connect it to, so I just had this like empty robot shell. Maybe I was younger than that. Yeah, I don't know how old I was when I made that. But yeah, anytime I had some amount of access to a thing that let me bridge the physical world and the computing world, I thought that was super cool. Like, the first microcontrollers I played with were the basic stamps, which were kind of like the closest thing you had to an Arduino at the time. There was a sort of built-in IDE that you could use, and they were much slower than an Arduino because the whole thing was an interpreted language. But they had that attribute of being simple to learn. You know, you could learn the entire microcontroller under it. You could have a pretty good idea of how the basic interpreter and all that worked, even if it wasn't open source. Then I think that became an on-ramp, just working with plain old PIC microcontrollers, which I mostly programmed in assembly, and that was lots of fun. Oh yeah, Thomas says the first I actually touched was the Basic Stamp 2, which rather dates me, but it pretty much set the direction for my life. Yeah, actually pretty much the same for me too. I mean, I remember lusting after the original Basic Stamp in magazines, but by the time I could actually commit to like buying one, I think, I don't know why, I guess I just skipped to the Basic Stamp 2. I remember getting one and being really into it and then building this project around it that was actually going to use two of them. And it was going to be this whole like complicated keyboard terminal thing where it had a alphanumeric LCD and like a modified keyboard from like a surplus Mac Plus or something. It was this weird thing. Yeah, I don't remember if I ever used the Basic Stamp 1. I remember being familiar with it just from reading about other people's projects, but then the BS2 was the first thing that I remember really doing much with. And then I spent a lot of time with like the PIC16 F84 and some of the PIC16 5X. But I guess that was when I started noticing how people were starting to cluster around particular microcontrollers in order to form a community. Like, I could choose any of the, PIC16 5X, EEPROM erase PICs and do a project. And I didn't really mind waiting the 10 minutes for the EEPROM, like for the ultraviolet light to erase your program. But, that bothered a lot of people, and, so more of a community was growing up around some of the brand new flash-based microcontrollers, well, EEPROM at the time. So the PIC16C84 was where a lot of projects started happening because you didn't need this separate piece of hardware to erase them, and you could erase them quickly. And then I remember even using those chips for projects that didn't really especially need them or any of the features, just because I could be pretty guaranteed that random hobbyists online would have a pile of them handy. I think I put too much ink on again. I guess the project I'm thinking of was an adapter that let you use a GameCube controller on your N64. Of course, because the N64 controllers were terrible and it would always wear out. But I actually kind of liked the GameCube controller, so I made this little adapter. It was basically just a PIC16 F84 small assembly language program. Lots of reverse engineering, at least what seemed like lots of reversing at the time. The actual basic protocol that you needed to transfer the button info wasn't complicated. Lots of people had documented that. But I wanted it to work with all the memory cards and rumble packs and stuff like that, so I ended up doing a bunch of N64 controller protocol reversing so that I could emulate rumble and the memory card slot correctly. And then it turned out that one of the limitations was actually that I needed to calculate this CRC value to prove that I was correctly responding to some of the packets, to basically calculate a CRC such that the N64 would know that the packet that I just sent it back is legit when it reads it and not a communication error. And that actually posed a problem on this this really basic PIC that I was using because I was low on CPU cycles. So I remember doing this weird hack where I think I assumed that the packet would just be a bunch of repeating copies of the same byte because that worked for the rumble pack. Because the rumble pack was this vibration peripheral that attached to the N64 if you weren't around for it. And so it was a way of adding vibration feedback to a controller that was never designed for it. And this worked via a memory card slot that the N64 had for saving games on the controller, which was kind of a weird idea. Not that unusual, like the Dreamcast kind of did the same thing. But that was the N64's version, was basically a little SRAM, like a battery-backed SRAM cartridge that you put into the controller. And so the controller itself had like an address data bus for that SRAM just exposed. And that's what they hooked the rumble motor up to. It was basically a memory latch that you'd write to, and you'd write like a 1 to turn on the motor and a 0 to turn off the motor. And so what I ended up doing in the controller was making a really minimal implementation of the controller protocol that you would speak over the serial wire in order to send like address and data pairs to that bus. And I implemented it only for the case where you're just sending an entire packet full of copies of the same byte, because that works for the rumble pack. Because it would just send zeros and it would send ones. I wonder, I mean, I guess you probably could have sent a sequence of something like zeros and ones, and then it would have kind of pulse width modulated the motor, but the problem is that would have only been modulating it while it's actually writing that packet, whereas most of the time you're spending is between packets, so that wouldn't really help. The games would always send all zeros and all ones. So I ended up with this very minimal implementation that would just do that, and then drive a... Well, no, it would actually send the commands to the GameCube controller to drive its corresponding rumble motor. Weird project. Oh, and Ellen's asking, how fast do inkjet drops evaporate in air? Can we make a raster picture with water drops falling? That's pretty cool. I saw something... I've been long fascinated with the idea of... I don't know. This sounds corny when I say it, but like, because like I don't really care that much about like fountains or like amusement technology that much. But maybe I do. I don't know. I like the idea of a fountain or something that falls and falls with an image, and I think people have done this with just a big array of valves. But then you end up with pixels, and so I'm wondering if there's a way to do it that actually gives you more horizontal resolution than just the number of control elements you have. So maybe some way that you can set up standing waves in the material that the water is flowing over. And then, so you could basically create, like, you know, what if you had like a one-dimensional, like a coarse one-dimensional array of acoustic actuators of some sort that would drive a wave pattern into a flat membrane that the water would flow over? I don't know. There are a lot of ways to do that, but it's fun to think about. And then what is... I'm also trying to parse what Mikkel is saying. This is what I think of when someone mentions assembly with a noise plug. Is that a... I guess all of you that can click on the link at home without having the music feedback into itself probably already know what it is. Oh, nice. Robert says so many people like the GC controller that Nintendo reissued it. Well, that's cool. I'm curious if anybody is really using that controller converter thing that I made. I was interested in the idea of just making adapters between controllers for a while. Ended up basically making one thing that went from USB to whatever controller I liked the most, which for a while was GameCube. And then another thing which was an FPGA that could emulate controllers on different systems. I didn't end up making that many of those emulators though, because it took so long to optimize the emulator to be small enough to fit on the FPGA that I had. But it was good practice at learning how to make Verilog small. It was like it was an old Xilinx. It was an XC4010, if anybody knows about those. 10,000 LUTs, I think. That was the same FPGA that I implemented a Space Invaders game on in the digital logic class that I mostly didn't pay attention to. This is about to get low enough that I'm not going to actually be able to print, so then I guess we know when the end is. In fact, I think we're running out of pressure here. I could put something under to, so you can see there's like there's a little hollow that the sticky note fits into, and it is now flush, so I don't have another sticky note pad handy, so I think maybe we just found our stopping point. All right. Well, I should probably actually rinse off this printing block before it dries. So I'm gonna do that and leave you with Tuco for a minute, but I will be right back. Cool, thanks for bearing with me. And I can wash this later. This is not delicate. The glass plate, I guess. Alright, ow. Next object for me to hurt myself on. Alright, next thing, we're back to this little printer task. This is my Orion Delta. On a previous stream, which was about a week ago now, we did the first half of the hot end rebuild. Well, not actually the whole hot end, just the resistors, so replacing the heater in the hot end. And so we ended up having to do this in two parts because you have to let the silicone, there's like a high temperature silicone that you use to attach the heating resistors, had to let that cure for at least 24 hours. Well, it's been like a week, so it should be fine. Let's finish this up. Oh man, this is also getting in the way between me and the monitor up there. Lund says, hello Tuco, did someone send Micah a Tuco in a box? Kind of. I do end up with these boxes that Tuco likes. I think he likes that one especially because it's in the warm exhaust air from the equipment rack. And then Len's asking about the other cats. Yeah, we can take a look at those. So Tuco's over here. The other cats have been in the bathroom, and yeah, I've been trying to keep them separate since they had a bit of a disagreement that I had to get in between, and I think the other cats were a bit freaked out. So the plan right now is to keep them separate and gradually reintroduce them when I can keep an eye on them and make sure Tuco isn't terrorizing the other cats. I don't think we've got Cat over there. Anyway, they're probably both hiding under the tub right now. The bathroom does not usually have a screen door on it. That is just bungeed up there temporarily. Alright, well, we've got that at least. Alright. So, last time we took apart the hot end, stripped it down to where the resistors enter on the sides. This is one of the sort of older style 3D printer heaters that are actually just based on using power resistors at way beyond their rating, and so they fail every once in a while and you have to replace them, which is great. So this printer uses 2 of these 6 ohm resistors in parallel, gooped up with thermally conductive silicone into this metal block. So we put the resistors in, gooped it up, and this was some temporary Kapton tape that I was using to hold a thermistor, so I can cut that off too. These want to be bent down, trying to be gentle to the resistors themselves. Also apparently covering up everything that would be on camera with my hand. So on each side, these two are both going to need to meet in the middle and then attach to a wire crimp. Might be worth referring to the video again, actually. We have 2 heating wires that are not quite the same length. Alright, one of them is long, one of them is really short. Can we get any more length out of this? I think this might just be stuck to the heat shrink. There we go. Okay. So this is just spliced in with the fan wire. Ah, so the heater has its own negative return, but there's a single positive shared between the fans and the heater. So this is going to be going right back to the power supply's 12-volt rail, and then they'll be switching all of them to ground on the other side to turn the individual fans and the heater on and off. I don't really want to disturb this existing splice, but this is really short, so I might splice a small additional bit of wire into this, as ugly as that sounds. James says, clearly put the long one on the further end since the resistors are non-polar. Yeah, that'll help. I think this stripper is for smaller gauge wire. I'm gonna grab a different one. We've also got this print, still chugging along. I mean, this one actually recently started. I started this one this morning. It is the latest iteration of one of the side panels for the winch. Okay, what actual gauge is any of this? Seems like maybe 18 gauge. Let's try 16 just in case. Yeah, I think it's 18 gauge. Okay. So I have that stripped just a little bit. I'm just gonna splice this to some of that white silicone insulated 16 gauge I've got. Since this will be a soldered connection, I think I want this to also be somewhat far from the crimp, since we need some cool down distance here. Okay, so let's tin both of these and then form them into some kind of mechanical joint. For anyone who missed the beginning of the stream, the main thing I'm blaming for the week-long gap between the last stream and this one was the complex cat situation that happened. So I agreed to help take care of these two cats. Well, I agreed to take care of these two cats entirely for like a month. Their cat mom is traveling, and they had someone here taking care of them who flipped out and couldn't take care of them anymore, and so now they're staying with me. And it's alright. The actual thing where I had to go and get the cats was a bit of a surprise, but after that happened and they acclimated, things seemed alright. And so, like Saturday night, I tried letting the two new cats out of the bathroom where I was kind of acclimating them to the space, and to let them just explore the entire place. And that seemed alright at first. And then some jealousy, I guess, that Tuco was still working on kind of came to a head, and Tuco started getting really mean to the other cats. And then I basically ended up kind of breaking up a fight between Tuco and Luna, one of the new cats. Tuco was kind of going after the two new cats, and they seemed like they were cornered. And so I got in between them and tried to pick up Tuco, and then he just unloaded on me and just like screamed and hissed and clawed. I hadn't really seen him do that. He did not like me getting in between them. Like, he wanted to be able to assert his dominance there, I guess. So that was frustrating. I ended up getting some wounds from that encounter, and yeah, it scared the crap out of the other cats, and they ended up running into this crawl space where it took a while to actually get them out. I had to like take apart part of the bathroom wall to get, there was like a hatch over the wall behind the cabinets, and he was like in the wall. It was really frustrating. Anyway, that seems fine. Oh yeah, Len was saying, I was wondering whether those scratches were from cats or assembling a winch bot. Yeah, definitely cats. Nothing hurts like a cat, you know? maybe a bigger cat. This heat shrink tubing is really bad. Let's just try that. This heat shrink is so thin that I think I'm gonna double it up and use another layer. Can probably also have that red wire exit slightly better. I don't know. That's fine. Oh, interesting. It's just getting to Thomas's question about whether anybody else is having stream dropouts. If anybody's having trouble with YouTube, and they missed the announcement about it earlier, there is a Twitch stream. If you go to twitch.tv/scanlime, same as my Twitter handle. All right. I think I'm gonna cut this wire so it's only a little bit longer. And use the correct stripper. Oh, was there like a noise? Yeah, that's my water kettle. It plays a tune when the water's hot. I think, yeah, if somebody must have refilled it earlier, and then it does that a few minutes later once it's done cooking, boiling. Come on. Maybe this was 20 gauge. Maybe it's also got a little kink at the very end that's causing trouble. How is the insulation stuck onto the wire like that? Is this maybe from being so close to the heater? Maybe the insulation is just kind of thermally set onto the wire somehow. Yeah, I don't know. It's tempting to replace that wire too. Unnecessary, probably, but tempting. Let's form the leads on this side. Okay. So I need to find the crimps that go with this. Here they are. Yeah, train whistle would be bad because I wouldn't know if it's T or a train. Well put. That's a huge problem. Okay, so these crimps. That seems a little too long. It's tempting to cut it a little shorter. Now I've dropped one of the crimps under the machine. Yeah, I mean, that would be fine. I'm just comparing the length of this wire to the length of, say, the thermistor wire. Wow. These thermistor wires sure are bent really sharply here at the edge. Well, maybe those go together. This wire is really oxidized. I'm thinking maybe I shouldn't have used 16 gauge wire because this difference in thickness is going to cause mechanical problems. And I'm also thinking that maybe the other side wants to be replaced also, because this end is kind of heated up enough that I don't know that I trust any of the plating on that wire anymore for a crimp connection, you know. Alright, let's just do that. Let's just put some nice 20 gauge silicone wire on both of these, and then hopefully that'll last longer. Oh, those thermistor wires look so delicate. They really need more. I mean, I'm going to tape them to the crimp once I add that, but I'm going to at least add some tape to this part that looks super fragile first. That's better than nothing. Oh, Jarrett is asking, I missed the stream where this printer was introduced. What's the fault? Yeah, it needed a new heating resistor in the hot end. It's just one of those parts that burns out every so often. I've had this printer for a while. It just doesn't show up on stream much because it just kind of works. This one was responsible for printing a lot of the small red parts in the winch bots. Yeah, this original wire is not as fancy as the silicone wire that I would like to use here. I think I also kind of want, man, I actually kind of want more wire stripped so that I can make a good mechanical bond, but like that's a limited resource here. Let's see if I can kind of clean out what's there on the joint. Okay, well, I've got a bit of an exposed hook there to wrap the other wire around. Cool. 20 gauge silicone. This stuff. So I'm just going to attach one end to each and then trim these both. Alright, that seems alright. That's a little better. That's gonna suck if it turns out I damaged the thermistor doing this. That's what I'm hoping to avoid. There's a sharp bit here. There we go. Do I still have room for 2 layers of this? Didn't have quite as much margin this time. Kind of. I'm just doing this because this particular heat shrink is super thin compared to what I'm used to. Okay, so now I can actually trim this to a good length, I hope, and put them in the crimps. Assuming I can find the crimps. Okay, So these are completely pinched shut in the middle, so I need to shorten both of these. I thought that they were going to overlap, but that's not how these particular crimps work. So let's trim both of these things. About half the length we had. Holding on to the pieces of copper as much as I can. Alright, so in the instructional video for this step, they showed just crimping this using a pair of side cutters to kind of periodically squeeze along the length of the crimp. Kind of like that. Let me see if I can get a slightly beefier pair. One of these two, maybe. It's already feeling like it's holding on pretty solidly. Like that. All right. Maybe a little zigzag bend is better than shortening it further. Some of you were weird and think it would be awkward if you had a friend over and you were printing a dildo. That's strange. I can't tell if this is really making a good joint onto both of these resistors, but I guess the ohm meter is not going to lie. We can test that in a sec. I'm going to try to do the same thing on the other side now. know about this, man. Got 3 ohms between the crimps, which is what we expect. I don't really like the crimps, but I don't know that they're really made to be liked. I think the next thing to do is to reinforce the thermistor wire a little bit. Maybe this Kapton's a little thick for the job. Let's take this away first. This is annoying. We'll use the dullest knife blade. Alright. I think at this point it's mostly just assemble it and see if it works. There's a reason not to use solder here, in case anybody's wondering that. This will get hot enough that solder is not especially actually going to help. And like having something on there that only helps when it's cold is probably worse than not having anything on there at all, because it masks the failures that you'll have later on. Yeah, 2 fan shrouds. Where's the fan shroud? Should have 2 fan shrouds, a washer, and a nut that go with all this. Ah, the other fan shroud's still attached. Great. So the fans, I think we want to invert the towers next. two cute little fans. This blower fan is for the layer cooling over here. It actually prints on, or it actually blows onto the model you're printing, whereas this is the fan that actually cools the part of the hot end that's not supposed to be hot, keeping it from being so. All right, get a better view here. Okay. Maybe the zip tie is the next thing to put on to start relieving the stress in these wires. I think that'll do it. Oh, how did this actually work? I think it was a little zip tie that went in diagonally like this. Yeah. Quite tell how right that is. And I need my wrench. Keeping the wires out of the way as I put this cooling shroud on. this screw needs to be rotated slightly. Not totally sure what this is hanging on yet, but I'm worried about it interfering with the heater wires, so I'm trying to keep those out of the way. Oh, maybe also the fan wasn't pushed in quite all the way. Is it possible it's also upside down? Oh. Maybe I need to refer to the video for this part. I feel like I might be putting this on upside down. Reboot my keyboard again. Nope. We don't need sound. Okay, this is the procedure we've been following. They did some diagonal too, all right. Oh yeah, I already did that part. Yeah. I think that's pretty much the same thing I was trying to do. I think they just pushed a little harder and were less worried about bending the leads on the resistors. All right. I'm also noticing that the vertical alignment of the fan within this little housing matters. I'm trying to keep an eye on that. I mean, it does seem like there's more to this than just pushing. It was definitely hung on something. Can I do this without the fan? Is it easier to put it on a different side? I think it makes the most sense back here. I'm gonna try putting that shroud on without the fan just to see what the fit's like. Oh, the fan was definitely what was in the way. That fits fine. Okay. It feels like the fan is just very slightly too big for the spot that it's in. But, there's a tiny, tiny ridge on the fan that's interfering with the edge of the that wooden piece. I think a tiny flat-bladed screwdriver might help. Possible I'm putting this fan in backwards. The fan only really fits in one way because of the way the wiring is done. So the fan's got to go this way, just the way I had it. Maybe I just need to jimmy this in there with something thin. Oh yeah, that worked. Using a thin shim, I got it in there. The fan is not going to come out on its own, that's for sure. I don't like this zip tie. I think this whole thing needs to be a little further down. Tighten that first and then put a better zip tie on. I'm just holding the heating end. It's covered in silicone and feels really weird. Okay. Okay, that only needs to be finger tight. Then this can go back. Okay. I think that wire arrangement ought to do. I don't know if we want a huge zip tie like that or a small zip tie. I think maybe the small one would work better. We're about ready to test this printer. You can actually get the backlight on the LCD to turn on when you're moving the towers by hand. Yeah. All right, let's see if this thing heats up. I need to grab an extension cord. Like I bought one. Yeah, kinda. To the extent that you can ever say that about like a 3D printer. All right, it's doing its thing. Let's try heating it. I might just rotate the printer so we can see the screen a little better. All right, I'm gonna tell it to preheat, and then we can keep an eye on the temperatures. Hopefully we'll just see it climb up nice and stable. All right, there's the fan. You can verify that the fan is spinning. You can tell the fan is a little buzzy, but it is working. Looks like the heater's working. I'm gonna start feeding some filament in there. Do you hear that snap? I'm assuming that was just plastic in the nozzle heating up, but just out of paranoia, I'm going to unplug that for a sec and feed some plastic in so we can get the nozzle something to actually warm. Let's cut off the gnarly end and then feed this one in. Oh, this front plate is a little bit destroyed on this printer. It still works, but like that piece of plastic is loose and it's going to break at some point, so I really should print a replacement. So I can just turn this until I've fed filament all the way up, such that it's almost in the hot end. Okay, let's try the experiment again. It is starting to smell like things that are getting hot for the first time. Nose temp is rising. Start trying to push plastic in and see if it melts a little. Ooh, yeah, we're getting a little ooze. Okay, to give the camera a few minutes to stop vibrating. Alright, yeah, nozzle's at like 170 and still climbing even as I'm pushing filament through. 175. And now it's holding at 180. Okay. Well, let's see if we can actually get this printing. Can't quite get the camera such that I can see the screen and the content of the printer at the same time, can I? Sort of. Oh yeah, let's print some of these. Winchbot nut wheel. I think I actually need some. Alright, so the nozzle's already hot. It's starting to heat up the bed. You can see that LED, maybe. It might be hard to tell what's actually on and what's just the sunlight, but... And when I had this in the closet, my spool mounting strategy was a little weird. I just kind of bungeed this onto the top of the printer and the shelf above it, and then ran it through sort of a crude pulley. For now, I just don't want this tangled with the power cord. Alright. Oh, it's definitely smelling warm. Yeah, I just saw a little wisp of smoke coming from the hot end, but it was momentary. And it's almost at 220. Yeah, it's putting off some kind of gross fumes right now, but it seems to be working. I'm wondering if it isn't a little overheating, but it's kind of hard to tell. I also just usually don't watch this thing print with so much light. Like, usually it's in a dark closet. Let's get a closer view of the actual print head. Alright, well, if this printer is indeed fixed, then that was pretty much the last thing I had scheduled for this stream. We might... I might just pay attention to the next couple layers here. Well, I'm certainly going to be paying attention to the next couple layers. I might as well stream that. It is a strange little robot, but it's been a pretty reliable thing. I mean, except for the resistor replacement, obviously, and that cracked piece that I mentioned on the side. This has been quite a reliable little machine. Let's verify both the fans are running. Yeah, fans are fine. James says, Delta. I'm sure it has some kind of goodness over a normal Cartesian system, but I'm not sure what it is. One thing that makes this system actually really good is that all the motors can be in the bottom. That's one of the main advantages, really, is that in this system, all the motors are in the base. Each of these towers has a motor right below it that pulls a belt up and down, and then the extruder is the Bowden drive over here, but that makes the actual hot end really light. I mean, we just took apart the whole thing. It's just heaters. Well, a heater, 2 fans, a thermistor. The entire thing. And so because it's so mechanically simple, you can make Delta bots really big, and they're still pretty accurate. Like, you can basically rely on existing extrusions to be your reference here. I don't know, they're just, like, they require just so many fewer specialty parts to make accurately than a Cartesian robot, it seems. This model, I think, is going to print solid because it's one of those really structurally critical parts. Yeah, this one's also relatively high speed for, given its other characteristics. Delta bot lets the hot end be light, and you can use that to put more energy into moving quickly. Yeah, I'm sitting like right where the gross exhaust is blowing, but it seems like it's working. Ah, bingo. James says this is the screw that holds the winch bot onto the mounting plate. Exactly. I've got another one over here that's already printed. Yeah, I can't focus that close, but making one of those. Oh yeah, Microhex says, I'm curious to see where the RepRap Helios goes. Yeah, that's another interesting printer with kind of a non-traditional design for moving around the print head. That one's kind of a robot arm. But it also has some interesting advantages, namely, like with a Cartesian robot, you need this kind of big infrastructure. Like, you need a box where at least, you can simplify that, right? Like kind of a printer bot style thing where you just have a couple of rails that are sort of moving against each other, but you at least need kind of one axis from each of X, Y, and Z, and those axes all have to stay straight. Whereas with something that just rotates, that seems like maybe you could require fewer precision mechanical parts to get the same results. Oh, good question from Whisperfist, who asks, total printer newbie question, how much power do these use? Max, average? It depends a lot on whether your printer has a heated bed, and if so, what your temperature is like what you're heating it to and what your ambient is. But, usually under 100 watts. Like, let's see, what is this using right now? Yeah, right now this printer is using 93 watts, and most of that's going into the heated bed, which is probably like 45 watts or so. I guess that's half, but yeah. I think the heated bed on here is rated for like 60 watts, but it's pulse width modulating it, so it's not going to be running it at the entire rating all the time. And then my bigger printer, the Type A, I think actually uses less power than this because it doesn't have the heated platform. Yeah, I mean, it's interesting that, like we have manufacturing robots now that are using less power than we used to think was reasonable for a light bulb. Yeah, the power supply definitely depends on the heated bed and what power it runs off of, because that's really the main, just because it's such a large area that you're heating, if your printer has a heated bed or an oven, then that's really where most of the energy is going. But you're not heating it that hot, and it's usually not a big area, so like those are rarely above like 80 watts or so in my experience. Yeah, this printer uses a PC, like ATX power supply, and it runs most everything off the 12-volt rails. And my Type A printer uses a 24-volt mean well supply. And then some printers run the heated bed directly off of mains, like 120 or 240 volts. That's just less common. I keep playing with this nut and like threading the nut onto my finger, and it's actually kind of sharp. Oh geez, Mikkel says for a normal 200mm square heated bed, rule of thumb is 350 watts. Wow. That's a big heated bed though. And I would assume that's like definitely peak power and not average. Yeah, that's more than I would have expected. I thought heated beds tended to top out more like around 100 watts or so. Oh, maybe it's because I'm standing up, but I'm not noticing the terrible smell anymore. Is it down here? kinda. Ugh. I wonder if this is the silicone going through some other curing stage, since I think this stuff is designed for automotive exhausts, and I think it does something, like it has some kind of secondary reaction once it gets to a higher temperature. I don't know. It could also just be baking off other contaminants. I guess I didn't make this one solid because it's definitely printing it with kind of a sparse infill, as you can see. The pulleys and, like, I think the capstan wheel I printed with a solid, well, no infill, but just a lot of shells so that it ends up being solid, in order to avoid having the, like, bumps caused by the infill grid. Yeah, I guess with this part I gave it a lot of top and bottom layers, but the infill didn't need to be that much. Yeah, you definitely don't, like if you're on a power budget, you definitely don't need a heated bed. Like if you're printing off of solar power, if you are trying to do like a portable printer, like I've seen people run printers off of like a backpack, and I like for that you probably could come up with a setup that doesn't need a heated bed. I don't know if you can see the dots moving in the background. That's actually our prints from earlier getting pulled across the table very slowly by the filament that's going into the printer. Alright, we've got two 3D printers to choose from now. We've got this one still going, back in the closet. That dark spot on the left is where this Delta usually hangs out. The other kind of robot. Yeah, lots of people are pointing out that the printer is just running the slicer's code, which I'm sure a lot of people know, but I still get a kick out of how printers are just, like especially this one where it's just running off an SD card. I just like how direct that translation is between bits and atoms. Just give it an SD card and then it pops out this part that you've programmed. This was sliced with Cura. Most of my stuff has been Cura lately. My Type A, I still use the slightly older version of Cura that they have a bunch of profiles for already. This was sliced by a pretty recent version of Cura, I think 2.5. something. The paths will often make sense if you think about the constraints, because like they're printing the infill as a bunch of line segments, right? So it's less about trying really hard to avoid over-printing an area and more about just reducing the number of line segments and then doing some kind of reasonable traveling salesman solution to them. Ooh, this card is nice and toasty. Michaela asks if I've ever considered making a time estimator. I mean, like me and everyone else who writes 3D printing software, right? I mean, everyone's got a time estimator and they all suck. For the time estimator to not suck, it would need to have a much closer coupling to the firmware than I think is really practical given the current printer ecosystem. And like, you could just go really all out and make a slicer and a printer firmware that were really well calibrated to each other, but it's only going to work for that one combination, so I think that's why you're not seeing a lot of people dumping effort into it. Yeah, I get what Mikkel's saying. I'm saying there's a reason people don't do it that way. It would be great. It would just be hard to maintain, and no one's going to actually do that. Like, if you want to maintain it, I'm sure people would appreciate it. But, like, the thing is, I guarantee you that more people are using the same slicer I'm using than using the same firmware. Both of these printers have slightly weird firmwares. Yeah. I didn't see why the time estimator thing came up, though. And then someone's saying, yeah, Mikkel's saying Octoprint does a pretty good job after a few layers, I guess. I guess I haven't really been timing it. I haven't really been treating those estimates especially seriously, but yeah, I haven't been measuring recently to see how far off they are. I just kind of take all 3D printer time estimates with a giant grain of salt and use them to compare design strategies, but not necessarily to plan when I finish prints. I mean, because like the estimates are going to be so bad, because like the machine that I have Octoprint running on, like its firmware does all sorts of acceleration stuff on its own, and then it just becomes a problem of keeping versions in sync. Like, if you were really well motivated to make this work on my printer, or if I were really well motivated to make it work on my own printer, then that would be great, but it wouldn't be a durable solution, because the problem is a configuration management problem, as far as I can tell. Ooh, giant grains of salt. Aw, Chris says, Tuco looks so comfy in that box, I want to be Tuco there. Yeah, I agree. I'm totally clicking on this mineralogy link for kids. Yeah, this is great. Hey, light. Can I zoom? Only if my keyboard's working, so I guess not. Yeah, I mean, I guess I haven't found it super necessary to have highly accurate 3D printer time estimates. Like, it's nice for design purposes to know how long something's going to take, but I don't find myself like setting an alarm to know when I need to go tend to the printer, since I don't know that that would actually work out too well. Oh, question in the YouTube chat. Sorry about that. I didn't notice until now, so thank you. How do you say that? Pospessler, I think, says, whenever I watch your videos, it makes me want to dump all my computers into the ocean. Yeah, I feel like that a lot. I think that's a common... I mean, I don't know anyone who works with computers who doesn't feel like that a lot. Maybe there are ways, but... And then Electron Ash says, is it printing with a slight slant to the right? It really shouldn't be. You might be seeing a curve on both sides of the part, actually, because usually the first few layers will have different shrinking characteristics than the rest, just based on, you know, it kind of needs to come to an equilibrium with the like pressure between the layer below and the print head above, and I think that equilibrium only happens once you get a few layers away from the build platform. So I think you're probably seeing a little bit of a side-to-side movement like that, but I would expect it to be uniform on the left side and the right side of the print. Oh yeah. Fred says the printer should play music when it's done, and Mikey says, but what song? This printer has a beeper. It's super loud and annoying. Hi, train. Nice timing. Yeah, I have Kapton tape over the beeper to make it less loud. Oh, with the steppers? Yeah, you could make noise with the steppers. It just might not be loud enough for me to hear outside the printer closet. Oh yeah. Yeah, the loud printer beeps suck. This one had a really loud beep. I didn't want to completely de-beep it, but putting Kapton tape over the hole helped it just enough. Robert says Steam controllers play beeps with haptics. Yeah, but that's designed for you to hear when you're next to it. This thing is like one of those beepers that's designed to notify you from across the warehouse or something. Oh, that would be great. Jarrett says, I want to design a drop-in replacement for the terrible piezo beepers that sound pleasant and non-stressful. I agree. That would be fun. You know, those have existed, actually. There used to be this thing you could get from Radio Shack, where you would just connect it to a power source, and it made this really pleasant kind of chime sound. And I don't know what they were intended for. I remember getting one as a kid and then wiring it up to a battery outside my bedroom and using it as a doorbell. Len says, but we can hear the stepper music clearly on stream. Who cares about what you hear? Yeah, well that works when the printer is on my desk like this. When I put it back in the closet, it won't be mic'd this way. Chris says, on my computer motherboard I use a magnetic speaker instead of piezo. Yeah, that's nice. I can't stand how modern motherboards sometimes include piezo PC speakers. That's just so wrong. Oh geez, that's a terrible idea, Mikkel. Those look loud. I think I've seen those in, like, surplus catalogs. Yeah, lower frequency seems nice. Like 440 hertz, certainly better than like 4 kilohertz. Ooh, Jarrett has a microwave with a horrible 4-second long beep that can't be stopped every time you open the door. That sounds terrible. Yeah, a good solid 440 hertz square wave coming out of a paper cone sounds pretty solid. I might try sitting down and see if the printer still smells terrible. Yeah, it does. It's getting less. But I might not want to run it in the closet right away, because I don't really want to fill the closet with terrible fumes. Maybe I'll print another one of these outside and then put it back in. This is kind of nice, actually. I'm like pretty much out of material, but we can just chat as long as we still have stuff to talk about and the 3D printer's going. It was kind of funny, actually. I found myself adding a beep to something recently. I was making an out-of-filament alarm for the Type A printer. Len says, you're in California, can't you just leave it outdoors all year round? That's a good question. I mean, I don't really have a good place to leave stuff outdoors here, but my shop doesn't really have, like, my shop is not entirely dissimilar from outdoors. Like, it's pretty drafty, and you can't really make it airtight. Jarrett says, like, have you ever considered do microwaves really need to beep? I guess you're right. You could just like send it a text message when your food's done, right? Okay, I do have a roof. I have a roof here. It's just that there are a lot of gaps in the walls. The windows don't entirely close, so you know, when it gets like actually cold here, I find myself wanting to work next to the heater a lot. I don't know. Jarrett says you're never more than a few feet away, and it's so loud that it's impossible to tell or to not tell that it's running. I have forgotten plenty of things in the microwave. Maybe that just means that I'm especially oblivious, but yeah. Fred says, like window planters, but with a 3D printer instead of plants. Yeah, that could be interesting. I wouldn't want to run a 3D printer outside because the draftiness would make the print quality pretty bad. Like, I would need to put it inside of a weatherproof box and then put it outside, and then there wouldn't be necessarily that much point for it to be outside. Putting like a server or something in a window box might work if you just want it to be cool. I have a former coworker who had a server of some description, or like a media box or some kind of computer in their garage because it was cool. But they also lived kind of near the ocean, and the computer ended up getting some corrosion. Mikey says, have you looked around your area in Google VR? No, I haven't. I haven't tried Google VR. Maybe I should. I kind of missed that being a thing. I mean, I've looked at it on Google Maps plenty. Oh, nice. Mikey says that there are a lot of 3D models in the area. Yeah, they do have a lot of good LiDAR data for this area. Fred says, ooh, fully conformal coat the server. You know, I think that might have come up in conversation when my friend was telling me about this problem. Yeah, I don't know if that ended up being a solution that he actually entertained, but I think it did come up. Mikkel asks if I'm going to upgrade my server rack to an Epic build. Is that like a specific thing, EPYC? Or do you just mean like something that's really fucking epic, you know? I mean, I think it's about as epic as I need it to be at the moment. But... oh, I see, that's AMD's new data center CPU. No, I don't have any reason. I'm not in the CPU market right now. I've got... well, gosh, how many even machines are there in there? Well, there are 2 Macs, which don't really count because they're Macs. They're always going to have slow CPUs. Then there's a Linux box, which is just like whatever I got cheap. I think it's like an i3. It mostly exists to run an NVIDIA GPU that does the encoding. But then my 2 actual PCs in there are both Intel i7 boxes, and I'm pretty happy with that. "32 cores, 64 threads, and a ton of PCIe lanes." Yeah, I mean, that sounds nice. I don't really have a need for that right now, but that's probably something that a lot of people are happy about. And none of the machines in the rack have especially nice motherboards, so like my I/O is limited by mostly just using kind of low-end computer motherboards at the moment. But it's enough for my current needs. I've got some slots with video capture cards. I've got a whole bunch of stuff attached over USB 3. Fred asks, aren't they multiple dies stitched together? I can't tell if that's tongue-in-cheek or not. Oh, you can see the hexagonal outline. I mean, it looks like it's been doing that for a couple layers, but it's a lot clearer now. I think this would be a lot more fun to play with if I had a screw to go with it. These are M8 by 100 millimeters. Basically, as a replacement for the threaded shaft, I found some screws, so instead of a shaft with nuts on both ends, we can just use long screws for convenience. The design accommodates either, but this is a little easier to assemble. Oh, interesting. Is this so this is a GPU architecture, a CPU architecture, or is it one of their, like, system on chips with both? I guess I could probably tell if I zoomed some of those images. Those pictures are pretty weird. I'll show you what I'm saying. Yeah, it's pretty weird. That, I mean, that's just a weird dye photo. Like, why is it spending so much area on interconnect? Is that just a larger, like they picked a die size and then used only part of it for a test, I guess? I guess what I'm wondering is if all that room that we see that's just interconnect, like, I assume that doesn't have to be there. We're only just seeing it because the chips are spaced so far apart. But anyway. I'm gonna turn on the fan. This printer is still putting off fumes. Oh, wait, was that top left picture the module, not the die? Oh, that explains it. So is that like some kind of substrate that is circuit board-like or wafer-like? Oh, interesting. So maybe they have... Maybe the substrate itself is like some kind of lower resolution lithography process that they can drop the dyes into. Oh, it's FR4. Huh. So they're just wire bonding it? Interesting. Yeah, I guess I would expect it to be more like ceramic substrate or something than FR4. But maybe printed on using a similar etching process. Yeah, I mean, I think microhex, that seems like it makes sense. Like, I would expect this to be more like the process that's used to make like a micro SD card. Oh geez, a 4096 pin package. Oh, wow. Okay, this was the latest picture. Wow. Well, lands, I guess, rather than pins, but wow. Oh yeah, Mikey points out in the YouTube chat that there's definitely an angle in the camera. I'm tempted to change it, although I think maybe I should just leave it alone in case I decide to time-lapse any of this footage. Yeah, man, 128 PCIe lanes. That's pretty amazing. Mikkel asks, what's the TDP? So the power envelope. Yeah, I'd be curious about that too. The LCD is saying it's 66% printed. TDP is stupid high. Oh, is that what that chart is? Oh yeah. So that TDP chart, if you can see it, tops out at like 170 watts. No, 180 watts. But yeah, so the max is 180 watts, but under 2.3 gigahertz, it's more like 150 watts. Then they have a reduced core version that's only 120 watts. There have been plenty other multi-die CPU modules, right? Like some of the big server things, like the power. Yeah, I just remember it being kind of a, like it seems like a dinosaur more like something that more than something that's really especially new at this point. But just the scale, man. I forget what I said about the camera. Let's get a new view. I'm about out of it. 30-minute window anyway. Oh, the gym next door is trying to get a content match now. Yeah, a lot of the Nintendo products have had multi-chip modules, right? Yeah, I mean, usually what I've seen for multi-chip modules has been like flash and a controller, or like a controller and a security thing. Oh, we had a successful DaveCAD print run. Yeah, I'm a filthy DaveCAD pirate, basically. I never paid Dave for my license. To go crew. It's kind of a variety of print qualities here. Well, that came out nicely. I mean, the pink should be pretty easy to write on with the black pen, even though it's bright. We've still got fumes. Only a little, though. Bob says, nobody cares who made the chip your EC2 instance is running on. It's funny though, because the CPU is one of the few pieces of hardware in the machine you're actually using directly in that case. So, like in theory you don't, but the CPU is actually one of the few pieces of hardware you really are relying on right there. Tapping the DRAM bus, yeah. You can see a little bit of unevenness like on the left side, which might have just been differences in temperature as I print. Since this is one of the draftier parts of the shop we're in right now. Oh, gotcha. Yeah, totally. I guess, yeah, Bob was talking about the context of, you know, the negotiation between like Intel/AMD and system vendors. But I just think about it from the point of view of like an implementer or security auditor where the CPU might seem really commoditized right now, but you're still really relying on everyone to get it right, and it's like if there are differences in functionality or behavior between CPUs, you will notice them from inside a VM unless the hypervisor is specifically trying to, like, unless it's like in a part of a CPU you don't have access to in the VM, or the hypervisor is specifically trying to make that difference less noticeable. Which is, I don't know of any complete solutions to that. There's usually a way to detect that you're being messed with. I mean, you can always time operations, right? And if you're in a hypervisor that's going to also mess with your sense of time, then you can usually detect that if you have any external references. And if you're in a hypervisor that's been specially constructed to be deterministic so that you can have your notion of time messed with, you can detect that. Because you can race multiple clocks against each other and detect the determinism or not. And then on the hypervisor side, you can simulate some of the non-determinism again, but it just becomes this game of cat and mouse, making detections and workarounds. And I mean, this was an interesting thought experiment for me a lot when I used to work on VMs. Like, if you actually wanted to make them really difficult to detect, what would that look like, and then what would the counter options be? But nobody really needs to do that, because every single VM detection mechanism I've seen in the wild is just so dumb. Like, they're not detecting differences in how the virtual CPU operates. They're not detecting anything that would actually be difficult to change about the operation of the VM. They just detect, like, is this registry key there that indicates you've installed the drivers or something? You know, the VMware tools or whatever driver set you're using. Or are they, you know, there's like one step better than that, is to like look at the PCI IDs and look like, oh, or not, actually I don't know if the PCI IDs would help you because it looks like an Intel chipset, but like hard disk model. You could look at the hard disk model and see that it's like VMware virtual disk. Easy to change, but nobody cares. Mikkel says, speaking of VMs, what do I want to run? What do I do if I want to run Windows and Linux on the same machine at the same time, passing the GPU to Windows? Does the Windows machine have to be inside of a VM? Because if you can avoid having the GPU driver run inside the VM, that'll make everything easier. And being in the VM, like, it should work, but there's just a million reasons why maybe it wouldn't. So I would definitely avoid making assumptions about that before testing it. Yeah, like, my usual solution for this would be to have a VM running on the Windows host, and then, like, depending on what you needed the GPU for, either run the GPU software on the Windows host or pass it through at a different level of abstraction. Microhex is using scare quotes around bug. I could see that going either way. I mean, it's certainly suspicious that it works in the Pro cards but not the consumer cards, but there are so many reasons why it might just not work that a bug seems pretty reasonable to me. Them not fixing it, not so reasonable. Fred is reminding us that there's the Windows Linux compatibility layer now. Yeah, that's been interesting. I've been starting to experiment with that a little bit. Kind of went down that rabbit hole a little because I wanted to make at least parts of my Windows streaming machine a little bit more remotely administratable over SSH if that's possible, but I was experimenting with that. And it's pretty interesting. I mean, it's basically, like, if you imagine what would happen if you just told a bunch of Microsoft engineers to implement a Linux kernel compatibility layer that runs ELF binaries and to build it on top of Win32, then it seems like what you'd get. It's an interesting object. There's a bunch of names people are calling this. Bash on Windows, GNU NT, Ubuntu on Windows. I mean, the official name is, if I remember right, is WSL, the Windows Subsystem for Linux. So it's implemented in Windows basically the same way that like Win16 or like OS2 compatibility or whatever would have been done. It's like another thing that sits kind of alongside Win32, like another way to write an application. So it's kind of like Microsoft's equivalent of Linux miscellaneous binary formats or something, but like it kind of implies a lot more of the operating system. So at least that's my understanding of it. Bob says it reminds me a lot of user mode Linux. Yeah, I can see the similarity. It does seem like, because user mode Linux is basically an implementation of, well, that's where they're different. User mode Linux is a Linux kernel that's been recompiled as a user mode program. So you're running a real Linux kernel, but it just has a totally different environment that it's connecting to, which happens to then be built on top of user space. Whereas the Microsoft Windows subsystem for Linux, it's not a Linux kernel. It's a cleanroom re-implementation of a bunch of Linux syscalls. So it's Microsoft's code. It's not pretending to be Linux. It just is a compatibility layer for running Linux applications. So naturally, anything that relies on a lot of in-depth kernel knowledge, even stuff like, you know, I think they've got some basic like procfs stuff, but like I would not expect like libUSB to work, for example, because why would it? Like literally, why would it? You would need something that implements like sysbus USB devices on top of WinUSB, which you could implement, but it seems really unlikely they would. I think they've been focusing on more basic services like file system and network, and they've been trying to kick ass at those while they can. Yeah, Fred says, want to have some fun, load X in WSL. Yeah, I've heard X does not work especially well, but that doesn't surprise me. Somehow we went from like 60% complete to 95% complete. It's already printing the last couple of layers now. Yeah, I was still kind of on the fence between writing the control program for Tuco Flyer, the camera robot that I'm doing. I'm still kind of on the fence between having it be native Windows and WSL, just because like if it's WSL, it might be a little bit easier to remotely log on or to remotely mess with over SSH. But the main thing that's that I'm stumbling on right now is that I kind of want it to have access to the joystick, which means DirectX. I mean, which means either DirectX or you know, Linux input subsystem, but I don't think I want, like, even if Microsoft did implement the Linux input subsystem on top of DirectX, I don't think that's the thing that I would want to use for that particular problem. Kel says percentage completion is just file size. Yeah, probably, but like, it's better than nothing. The kilowatt is still saying the printer's around 100 watts, a little bit under. Oh yeah, James says I've not done much with the WSL because screen doesn't work inside of it. That's sad. Yeah, I haven't investigated what's really going on with this, but it does look like they're doing some weird terminal emulation. Like it looks like there's something. Oh, maybe I'm conflating that with what's going on with SSH. But yeah, it seems like they might be translating like VT100 at some layer back into like Win32 style console, but I don't know where that's happening. Like I think they're probably doing something that ends up basically looking like a kernel-based terminal emulator that then gives you like XY characters and colors, which is what Windows likes to work with. And then if you SSH into that, they're then converting that back into VT102, because it looks like if you SSH in and then use like command or anything else that has a Windows console attached to it, that it's then converting those into emulated VT100 codes. Oh, good question from Mikey, who says, does the printer stop the feed while the head moves across the piece, or does it rely on it being a quick movement? There's usually a threshold where if the movement is more than a certain distance, it'll actually retract the filament to kind of put a negative pressure in the head to keep it from oozing. But if it's a very quick movement, or it's a very short movement, then it's not really worth it, so it doesn't. And usually that threshold is like a millimeter or two. There it is. Got to resist the temptation to just yank it off immediately because it needs to cool down. It's still going to be soft. But yeah. Well, we made it through a 3D print, and so did the printer. Let's take a look at the hot end. It seems like it's still fine. So there are the crimps we just did. There's all the high temperature silicone, still siliconing it up. All right. Mikkel says throw the bed in the freezer. That sounds inconvenient because then I'd have to recalibrate it when I put it back on here. I like to just leave the print bed on and not have to recalibrate it very often. Ah, that's toasty. Ah, yes. That feels nice. The thermistor says that's still at like 57 degrees, which might be a little warm, but I've also got some cool air coming from the fan right above me. Cold spray. I'm not interested in breaking the glass print surface, thanks. Hose it down. Yeah, I mean, I could just spray some isopropanol on it, but I'm not really interested in thermal shock at the moment. There's the other one. I could go ahead and glue in the nut, but that'd be silly. And Mikkel's asking if it's borosilicate. It should be. I still wouldn't want to thermal shock it. Anyway, this is about a good wrap-up point for the stream. Let's see if there's any last-minute cat investigation we can do. Which one is the cat? There we go. For anyone who missed the intro in the beginning of the stream, I have these two cats that I'm temporarily taking care of for about a month. And so I've been going through this process of getting them used to the place and then seeing if them and Tuco get along. And so I had introduced them into the bathroom to give them like a spot where they could feel safe, and gave them a couple days to get used to that spot. And then it seemed like they were pretty happy with, with leaving come Saturday night or so. And so I tried that, and then the peace lasted about 12 hours before Tuco started picking fights. And so now I've been trying to let them kind of hang out with this screen in the way so that they can see each other but not get into fights, and then I can let them out for short periods of time where I can actually keep the peace. Oh, that's right. I had this whole plan to show you guys some cat videos that I had on my phone, but then I totally spaced it out. Because I knew it would be hard to actually get these two on camera since the wire for the camera doesn't actually reach into the bathroom, but I made some videos earlier. Yeah, that cute little black one is Luna. She's really sweet. She is super shy, so I'm sure she was hiding way back underneath the bathtub just now. Now I've got Tuco right here at my feet. I think he wants to hunt something outside. You could almost see all three cats on the screen there. Yeah, this black cat is so pretty. Yeah, her name's Luna. She's had kittens, and she's really sweet. Even though she's shy, like once she knows that you're all right, she just gets super affectionate. Yeah, I feel like a proper cat lady. I'm enjoying that role. Oh yeah, this one likes water too. Hey Tuco, you want to hang out up here? Oh yeah. So that's not Tuco, that's Cloud. Cloud has the white tummy and pointy forward ears like that. Yeah, I really just need some cat robots now. I thought Tuco was gonna walk in the, walk on the pink inked plate and then get ink on his paws. I think he avoided it. Do I have anything else relevant? I took this just before starting the stream. This is where the printer was at. Robert says, finally, a use of the word cloud that doesn't deserve to have to but applied to it. Yeah, I think that's about right. I mean, I think his name works pretty well. He's super fluffy, but he's also really dense, like physically dense. Like he's a big cat, and so he's really fun to hang out with. Oh, my phone was trying to go into low power mode. Mikey asks if Tuco's ever looked like he was going to attack a printer. Tuco doesn't seem to have any interest in attacking machinery. Actually, he's more interested in 2D printers than 3D printers. He does try to get the paper out of the 2D printer while it's printing sometimes, but he doesn't seem to care about the 3D printers. Aw. I think I'm going to have this printer do another one of these same parts out here before I put it back in the closet. Just for debugging's sake. I would rather it burst into flames here than in the closet, but I think it's going to be fine. Thought I could use that to help get this off, but... There we go. Where? I don't exactly know how the screen just went blank right there. Sorry if that was there for a minute or so. There we go. Alright, well, I don't think I need to stream the next one also, because it's hopefully just going to be the same thing over again. Yeah, I have some like little spudger spatulas, but they're all in the 3D printing closet. I shouldn't have just wiped that, because now I'm getting finger oils on the build platform. Alright, well, I hope everyone had a good time, or left. I hope you didn't stay while having a terrible time. That would be the worst of every world, right? And yeah, thanks for stopping by. It's always nice to stream, and sorry I went so long without streaming. I'm going to try to keep them frequent, and yeah, I'll try to keep everyone updated on the cats, because I know that's a complicated situation that many people are probably interested in. So thanks again for stopping by. I will see everyone soon.